So, welcome to Git Zero to Production. This is a free code camp talk all about Git version control. So what you can expect to get from this talk is a little bit more about the basic Git commands and helpful Git paradigms such as what is branching and why do we do it and why should you do it. Git workflows for both personal and collaborative work projects, so things you can do for your own personal projects, or when you work on more advanced projects that are open source, or if you do something in a production environment for a business. These workflows are applicable to pretty much any scenario and are some of the most widely used workflows with Git. And hopefully by the end of this, you'll be inspired to learn a little bit more about version control and how you can leverage it with your work, because there's some really cool stuff you can do with it. All materials presented will be available at this link, which I will copy and put into the chat for everybody. So, who am I? My handle on most websites is Tall Guy Jenks, and before you ask, I'm 6'6", so that's why. I'm a DevOps Information Technology Associate for Covered California, so I work for the public sector government here in California. And there will be links to like my CV if you care. I also have a YouTube channel where this video will be posted and where I post a lot of videos around tech, note-taking, programming, that type of stuff. And then I have a bunch of my social links if you care. So, jumping right in. What is Git? Git, and as it's defined on its website, is free and open source distributed version control system designed to handle everything from small and large projects with speed and efficiency. It's version control. So if you want to ever roll back something after you make a change, this is how you do it. Where did it come from? Linus Torvalds, the creator of the Linux kernel, is the one who created Git. Basically, there will be a link to the short history. It's like a paragraph. Basically, he got pissed off at a proprietary version control system and said, no, we're not staying with this, and I'm going to make my own thing. Now, it was added to eventually, and it is a little bit better nowadays, but there's a lot to Git, and there's a lot to learn about it. But like 80 to 90% of what you actually need to know is a very small subset of what Git can do. And especially with all the tooling that exists nowadays, extensions, GUI apps, lots of things exist to help make Git and using it easier, because something written by a kernel developer is probably not as accessible as some other types of tools. So there are a lot of things that are not the original Git implementation, but that are really useful. So why is it useful in general? In general, Git will allow you to do distributed collaborative work with other people. So I can do some work on a code repo, somebody else can do some work. You could have 100, 1,000 people doing work on the exact same code base, merging changes and making changes and dealing with each other collaboratively to make changes to code. It is fast and efficient because it takes small snapshots. Basically, if you are going to get all the changes from a Git repo, it's not like a copy and paste operation where I need to move 30 megabytes here to 30 megabytes over there. It's here's 30 megabytes of code, but I've only changed 2 lines, which might be, less than a kilobyte of memory. Well, Git's not going to copy and paste the whole thing because that's an expensive operation. It's only going to change exactly what it sees from left to right. So that it's hyper efficient and only changes what has changed, which makes it very, very awesome when you're trying to pull large things or make constant frequent updates to some large code base over a potentially not so great network connection. And frankly, CLI tools or command line interface tools are hyper efficient. If you use the CLI, the command line, then you will know how efficient and powerful and expressive it can be. You can do a lot with a little, but don't you shoot yourself in the foot with it, so be careful. So why is Git useful in practice? It allows people to work independently of each other. I can work on changes, and every single one of you can work on changes at the same time as me on the same code base. We can work without having to deal with each other, such as with a check-in system. Things like SharePoint, if you work in a Microsoft shop or ever use SharePoint, you can't check out a document at the same time as somebody else. One person can have it checked out. What happens if they forget to check it in? But then I have to work with somebody, hey, check in your document so I can check it out and make my changes and then check it back in. And then you can see how this starts to get a little tedious. Git allows you to circumvent that and work on your own copy at your own pace on your own time without having to deal with anybody until it comes to the final merging process. Git will give you a complete version control history of the code. So you have complete retention and the ability to roll back. I can roll my repo back to a point 3 years in the past if I wanted to, at a specific point in time where the code looked a particular way. And I can do that at will. I have complete retention, so the entire history of the file is retained. So I can look back 3 years and say, I knew there was something that worked in this file, but it only worked 3 years ago. I'm going to go look at the code as it was then, copy that snippet, and then bring it into my current repo and just paste it. You know, that's something that you could do. And branching is cheap. Branch early, branch often. Branches are amazing. And we'll get into more about that later. Git can also be efficiently used on the CLI. And like I said, lots of tools exist for it. And just to poke a little bit into that, you can automatically set aliases and chain things together and define your own commands that are much less typing, so that you can string together 7 text characters that perform 17 Git operations if you so chose. There is a lot that you can do on the command line to make this better. So the differences between Git for personal projects and for production. Now, both of these examples could be used for your own personal projects, or they could be used for production. It depends. I mean, if you only have one branch and that's master and you're constantly pushing to master, or in this case, I'm just going to interchangeably use production and master and main, whatever, all the same thing. I'm just going to refer to it as production. So when you are just merging something straight to production, that's volatile. That could impact users. On your own personal projects, you're not making something for 15 people. You're probably making something just for yourself. So it's not quite as impactful. But if you work in an enterprise agency, a big business, and you are making code changes that affect hundreds, thousands of users, you don't want to just push straight to production. So the difference between personal projects and production are usually branches. Now with personal projects, you don't need to branch. You can, especially if the project is big. If you're using open source, branching helps with release and just staggering, different stages of code development, testing, and finally release and production. So we'll look into each of these examples progressively. So personal projects depend on scope. No one else is really touching the code, and you can branch if you want to, and we're going to work through each of this. Now, these step-by-step instructions will obviously be available at the link that I sent to you all later, and we can walk through these now, and you can do this on your own too. So the first thing you need to do to use Git is to have Git installed. You can just search Git on Google or any search engine and look for the website. Now, we're going to make a brand new repo, completely empty, and you can just go to this link, github/new. So going there, I'm going to create a brand new repo for myself. So I'm just going to call this FCC test. There we go. That's all I need. Hello world. And that's all I'm going to do. Create a repository. It is now empty and blank. So once you've created a brand new repo on GitHub, there is this link right here. Now, I'm not going to get into SSH keys, HTTPS, whatever, or even the GitHub command line. Those are out of the scope of this talk, but to just keep it simple, all you really need to do is just have HTTPS, and to get started, that's all you need. So I'm going to copy that and go back here. So next thing is open up your CLI. On Windows, I recommend Git Bash, which you can get from Git's own website. So this is also where you can install Git. Linux, just about any terminal emulator should work. And macOS, I haven't been on macOS too long, but I use iTerm 2, but the terminal itself works just fine. Sorry about that. So I got my terminal open here on the left, and I'm in the current directory for this VS Code instance. And I'm going to navigate where I want to put this repo. So I'm going to go up a directory. And now I'm in my talks folder. I am going to pull that repo. It's empty. I'm going to pull it down from GitHub and put it onto my computer, my local machine. So I'm just going to do git clone and paste the link. So I'm cloning the repo. I'm making a copy of it onto my local machine. Now you notice that this looks like a normal website, except it ends in .git. So enter, and it will say, you appear to have cloned an empty repo. Yep, that's what I intended to do. So now we have it. Now, if you weren't in your exact folder, you can navigate to where you want to put your repo using these CLI commands. You can list what's currently in that folder. List LA will list a long and verbose output. PWD will print your current working directory, tell you where you are, and CD will actually take you to somewhere, change your directory. So with those three, you can navigate to where you want to go and put your repo there. So now that you have your blank repo there, what are we going to do? Well, first thing is I'm going to go into it. So right now you can see that this says main right here. This is because I'm on the main branch of a repo of mine, my talks repo. So you can ignore this. Imagine that this wasn't here. So if I actually was outside of this, I don't have that there. So that's just decoration in my terminal. But if I go back to talks, and then I want to go to FCC test, I am now inside of my new repo. It's empty. ls to list the files. There's nothing in there. Give it some verbose output. Nothing in there. There's a .git directory. That's what Git does. That's all that. Everything about Git is in this hidden folder, but you can ignore that. So there's nothing in here. I'm on the branch master, and that's it. So let's run a couple commands. First thing I want to do is I just want to check what's the status of this repo. So I can run git status. On branch master, no commits, nothing to commit. You haven't made any changes. There's nothing going on. It's empty. That's exactly what we would expect. I can run git branch and see what are the current branches I have available in this repo. And there's nothing other than master. Yeah, it just says end because there's nothing else other than my master branch. So now we're ready to get started. You could continue and just use the CLI for different things. You could use Vim, we could use CLI commands like touch and make a file, or we can just do an easier way and do it in VS Code. So that's what I'm going to do to move forward because you all might be more likely to have some experience with VS Code than a lot of experience with the terminal. So we'll just start there. Now I have this opened so I can actually do the presentation, but I'm actually going to add another copy or another folder to this workspace, which is the actual repo that we just made. So you can ignore some of the complexity of this. It's not really relevant. Add folder to workspace. And I'm going to add FCC test. Okay. I'm going to close that. And I'm going to open up nothing. So now that we have the repo open, it exists here. I can collapse that because it doesn't matter, but we have a repo. I want to make a new file. So what we typically make is a README. So I'm going to new file, readme.md. I want to mark down README file. Great. VS Code is really great because it will intuitively tell you different things and what's going on. So with this, I now have a new file. That's why it's green. So I can save that, and I have a new file. Now there's a little menu over here for source control. I'm not sure if you have to install a plugin for that or not, but we'll get to that. So we have our README, and I'm going to move it over here so we can do both of these at the same time. Great. Now we're going to add some content. FCC test. This is my repo. All right, I have now added some content and saved my file. Now I can also, at this point, open up another terminal, which is my comfort zone. And I can say, what is the status of this repository? So I'm in FCC tests, which we can see here. I'm on the branch master. I want to say, what is the status? Git status. I've made a new file, and now it says something. There are now untracked files here. This means that you have added something brand new to the repo that didn't exist before, or made a change, and currently it is not tracking those changes. It doesn't know it exists. It's blind to this file. It doesn't know that README exists. So we want to actually add README to version control. We want to get it into the repo, and we want to subject it to version control. We start that with git add something to version control. I'm going to add the README. Okay. Now you can see this in my terminal anyways. This has changed, and now it's a different color. This usually just indicates visually what git status would tell me, which is there is a new change to be committed. It is now tracking this file. It says there's a change. It's a new file. It's called README. So how do we progress from here? So now we're going to git add README. We're going to git commit. So we could do something different and use some different interfaces, but we're going to go through, continue with the command line, and we're going to expand a little bit on this later. So I'm going to say git commit. I'm going to commit this file to version control. I've staged some changes. I said add this to version control. It is staged. It's saying I'm ready for you to commit this. Now we actually need to follow through. Commit this to version control. So commit -m, which is just the flag for this is my commit message, just so it doesn't pop open a menu. I'm going to say init readme. Okay, now if I hit enter, that will commit this new file to version control onto this branch. So now on master, I have committed those files, but that's only on my local computer. Now everything's green now, everything's good. If I do git status, nothing to commit, everything's clean, we're good. But what do we do here? So you've only made changes to your local copy of the repo. We need to make changes now to the remote. So that's going to be some very important terminology to remember, is that when I say local, my camera is going out. So when I say local, I am referring to your computer. When I say remote, that is referring to the actual Git repo on Git, or your Git server if you're working in like some business. So what we need to do is actually push that to the remote location. Push it up, git push. So I'm going to git push, and it's going to actually be connected, and it's going to say, hey, you got a new branch. So why did this happen? So Git said, hey, you have a master branch now on your local machine. It was an empty repository. So now you've actually added new changes to version control. I want you to put those onto the remote. Well, now you need to actually make a branch on your remote repository. If we go over there, there's no branches over here. There's nothing here. It's empty. But now if we refresh, there will now be a master branch with our README, and now it's on GitHub. And that is the basic workflow of a personal project on GitHub. There's only one branch, that's master. You make changes, you add them, commit them, and push them into quote unquote production. And now it's on GitHub. And that's like usually 99% of everyone's workflow. And that's it. So we can check the remote, we saw the changes, and you're done. That's it. So now comes into branching. And before we get into branching, I will pause for any additional questions and to check on the technology that's going on here. So, all right. And I will edit out some of the screenshots here. So before I move on to branching, does anybody have any questions? Okay. Continuing on. So what is branching and why is it important and powerful, and why should you leverage it? So with branches let you make a copy of your own work on a different branch. And this will look something like this. So we were on the master branch right here, this little blue line. But when you make branches, you're branching off, and you can think of this literally like nature. It's a tree. This is your work tree, and this is a branch, branching off from the trunk. The trunk is your production environment. So we can branch off, do some work, and then eventually merge it back in and make the trunk reflect what we were doing in the branch. Now that sounds like a lot of terminology, but in essence, what is happening? What is happening is you are making a copy of your current, whatever branch you're saying, but we're just going to say production, master. You are making a copy of that branch, master, and naming it something else. So if I have master, I could have feature, and now I can work on a feature. Why would you want to do this? Well, let's just say everything in production on master is stable. It works, don't touch it, it's not broken. But we want to add something new. Well, you're not going to add it in and then stuff is broken until you finally get it working and it's fixed. No, you're going to go to a branch that is a direct copy of production, make your changes, it's broken, fix it, code, and then it's finally working. Then what do? Well, your feature's done. You might have other people peer review it, or you just say, yeah, it finally works now. I'm going to merge this back into my master branch because now it's ready to be out there. It works. It's not broken. So in that case, that's usually the funny joke in IT is like, you're not going to test in prod. You're not going to just play around in production and start nuking things. you're going to put it into a secure place, do your stuff over there, and when it's ready, put it into production. And so in essence, that is what branching is. That's it. And branches are not literally a file system copy, like copy paste, and now you went from 30 megabytes to 60. No. Branching is literally like a pointer. For anybody who has any experience with low-level system languages, dealing with memory management, it's literally a pointer to a commit hash. Now, don't get confused by that. Really, each commit, every time we run git commit, it gets a little tiny label. Every time you make a commit, it adds a label, another label. So this was a commit, this one was a commit, and so was this one, so on and so on. So when I make a branch, it's literally pointing at a commit, saying, hey, this is a copy of this, and then any additional changes I make now progressively move forward into its own commit with its own unique hash. And all that means is that I can uniquely identify what work is happening at what point and on what branch, so that I can effectively traverse through different stages and branches of code. So what we're going to do first is we're going to actually make we're actually going to check our current branches. So I'm going to tidy up a little bit here. Git branch. What are our branches? All we have is master. It's not empty anymore. That's because we actually have something in here. It's not an empty repo, and we pushed it to the remote. So we actually have a branch now. And that is denoted in my terminal anyways by this green color and the fact that it has a star next to it. Whatever branch you're on will have that star next to it. So Q to get out of that. And we're going to make a new branch. It's very simple. We can list our branches with git branch. That'll tell you what you have available, but you want to make a new one? It's just git branch and then type the name of what you want. So what do we want to make this branch called? Let's just call it new branch. Very, very great intuitive name there. So let's actually list out our branches. Oh, there it is, new branch. Now, if I did any sort of diffing or wanted to look at the changes between these two branches, there wouldn't be any. At this point, new branch is just a copy of master, what I'm currently on, production. So what the power of this is now I can switch over to new branch, make my changes, and I don't affect production. Now you can also, instead of having to run, at this point, I've made the branch, but I want to switch onto it, I can run git switch and say I want to run new branch, and now that will switch me to my new branch. It says so here, git branch, it'll tell me, yep, you're on that one. So that's two commands. We could be a little bit more efficient if we wanted to. I'm actually going to reset here. So I'm going to do git branch. Oops. So if I go from now, I've deleted the branch, so you can ignore some of this. This is just me setting up. Now the branch doesn't exist, but let's say we want to make and switch to our new branch in one command. Well, we can do git checkout -b and then our branch name, new branch. That will automatically make it and switch you to that new branch in one command. Now, switch is the newest command that they actually prefer you to use for this. Git checkout is kind of overloaded, but that's neither here nor there. So now we just create and rerun through the exact same workflow we've already done with the README. We're going to make a new file. So I'm going to make a new file. I'm going to call that FCC test, and I'm going to say testfile.md. Yep. Hello world. And I'm going to save that, close it, and now git status, if I could spell right. And it's the exact same as before. We have a new file. We need to add it to version control because right now Git doesn't know it exists, other than it's saying, hey, something's going on there. What is that? So we're going to say git add. We're going to add the test file. Git status. I'm going to clean up there. Git status. Saying, hey, yep, new file. We're going to add this. It's ready to be committed. So git commit -m init new file. We're going to commit that to what branch? Oh, we're on the new branch, not the production branch. So now, yep, we're on branch, new branch. There's nothing to commit. We've already committed it. What do we do now? So now we're going to run git push. Now this isn't going to work Why? Git push, we don't have a branch on the remote repo called new branch. It just doesn't exist. There's nothing, there's only master up on the remote repo. So this is where you actually need to run something different, which is git push set upstream origin new branch. That's a lot to type, but really what you can just do is git push -u, which is set upstream origin new branch. Now, what does this command mean? Because sometimes running a command, yeah, you can just run it and it gets the work done, but what is it doing? Git push is saying, take something from my machine, my computer, and put it onto the server, whether it's a Git server or GitHub, doesn't matter. So it's saying, hey, push something up there. Set upstream is saying, hey, this is the most advanced and most up-to-date copy of something. Tack it on to the end of whatever is currently up there by this name. What name? New branch. That's the name of the branch. So when it says push-u origin, that's saying set the upstream of origin. Origin is your remote repo. Anytime you see origin / and then a branch name, that is the actual branch on the server or GitHub, not on your computer. So you could have main or master on your computer, but when it says origin master, that is actually the copy on the server or GitHub. So it's a very important distinction to make when you're trying to mess with branches. So when I say push -u origin, I'm saying, hey, set the upstream, the most recent copy, tack it onto the end on the remote repo for a new branch. If new branch doesn't exist, we're going to make it and tack all these changes onto the end. So when I run that, it's done. So now, oh, new branch. New branch is equal to new branch. And this is a lot of output for basically just exactly what I said. We now have on the remote a new branch after I refresh. So you'll notice right here, I'm on master. Where's my test file? It's not on this branch. If I go down here, new branch. And that, once it switches, is where our test file is located. You know, we are also one commit ahead of master. It was an exact copy, but now we've added a new file to version control on this branch that spans off of the master branch. Okay. So we've committed our file and we've pushed it to the remote. And at this point, honestly, it is just easier to do the PR or pull request process on GitHub. There are plenty of ways you can do this on the command line, but just doing this on GitHub is honestly easier. Or if you're using something like GitLab or Azure DevOps, it doesn't matter. So we are going to, we could compare and pull request because this is a branch off of master. So I could pull request and say, hey, my branch, new branch, came from master. I want to merge it into master. I'm ready for that. So you could do that here. And what that might look like is this. I'm saying, hey, the base is master, where we came from. And I'm comparing my new branch, the thing I made, to this and saying, hey, am I able to merge? There's no merge conflicts. I didn't put a 1 on this line where in the other branch it says 5, and there's no conflicts. Everything is the same except for where the changes can just easily be made. That's about as simply as I can put it right now. But in here, it'll also say, these are the commits, what happened, and then here's, what the changes are. One file changed with one addition. The addition is new content in a brand new file, which is maybe what you're familiar with seeing on GitHub. But we're not actually going to merge on GitHub. We're actually going to try it in the command line first. So before requesting a merge or getting feedback, you might want to make some final revisions to the code. And what you can do is make your changes and then run through the exact same process. So we could make some changes and say test file. These are my changes. All right. So we talked about a pull request to somebody who's responsible. They said, I need you to add that line into that file. We're like, okay, I will do that. So now I can check git status and say, yes, this file is modified, but the modification I made to that file is not under version control. Git doesn't know, Git knows that the file has been changed, but nobody else knows. I haven't committed this change and I can't push this change because I need to add that change to the version control process. So I can say git add test file, and I'm not adding the file brand new to version control. I'm saying only the changes that happen to that file are now being added. So add it, git status, It is modified, not brand new file like it said before, but modified. We are now ready to commit this and then push it. So git commit -m PR changes. We have committed. So now our branch is green. We're good to go. So git status, everything's clean. We're ready to push. Now, I'd had to push with -u, origin, all that junk earlier because we didn't have the branch titled new branch on the remote repo, GitHub, or the Git server. But now it is up there. So do I have to do anything new? No, I can just run git push, shove those changes up to the remote repo, and we're done. That's it. If I go back and I go to that branch, it will actually have the changes we just pushed. These are my changes. And the commit from 40 seconds ago, we can go to that, and it will also tell you, right there, PR changes. This is the commit we just sent. There we go. That's it. So that is, branching in a nutshell. We can create them, push them, but now here's the magic, is that we can merge them in and say, yep, those changes are ready to be put into our production environment. Put it onto the release branch. We're going to release it into the wild. Other people are going to use this code now. So all we have to do that on the command line is at first say git switch to our production branch, or whatever branch you want to be the destination of these changes. So I'm going to go to master. In this case, my production branch, I'm ready for those changes. Bring them in. So I'm going to say git merge. What am I merging into my current branch? The other one, new branch. Git merge that other branch into what I'm currently sitting on. And now we can see some updates here. I'm not going to get into like fast forwarding or any of that other type of rebasing or any of that stuff. But for what you might care about in this is that we have merged all the changes. Everything different about the branch titled new branch that differed from master has now been added to master. These are now two identical copies of each other. They are the same because we've merged them. If I went back onto new branch, made some new changes, now they differ. Now they're branching off of each other again. They're not on the same line, on the same commit hash, because they are different. So for now, they're the same. They share the exact same point in time. And we're done. That is merging. I now have changes in production. So we can also, at this point, let's just say I'm on my repo for the branch that we just merged. It's not deleted. It still exists. We merged it in, but it's not gone. So if I go here, I can actually add a new file. I can do a bunch of different things on GitHub. I can create a new file. Well, actually, before we do that, why is it saying I'm 2 commits ahead? I thought I just merged. Oh, so on our local machine, my computer, Bryan's computer, I merged my feature into my production branch. But I didn't push that to the server. The server is still exactly where it was before the merge. It doesn't know that the merge happened. That was only on my computer. So what do? I'm on master, git push. That's it. Now I'm pushing all the changes up to my server or the remote branch of master. So I merged in new branch and I have pushed all that, my current copy of master up to the server. That message is gone. There's no pull request to do because they're exactly the same. It's even with master. They're exact copies of each other. If I go there, it will have all the changes exactly how we made them on the other branch. There we go. And it will also have the exact same commit. So we made that commit, PR changes, on new branch, but it's right here because basically I took all those commits, all those little nodes, those dots, and just drop them on to the end of my master branch. So master branch fast forwarded and moved forward. So what happens if we add changes on the remote repo, the server, or GitHub? I'm going to go to my branch and make some changes. This is exactly the same as if somebody else had a copy of the repo, made changes, pushed them to the remote repo, this repo on GitHub, and had their changes merged into master. You now have out-of-date code. Code on the remote repo is up to date. but you don't have that code. You only have what you copied down earlier. So they've made changes, which is what we're going to do now. The change is create new file, not upload. 1 second. GitHub is slow today. Okay. I'm going to create a new file. I'm going to call this something unique here. Remote changes.md. Okay. This was made on GitHub. The remote. All right. And I'm going to make a commit. This is just like doing it in the command line, but with a GUI interface. So now my branch on FCC test, oh, I guess I put it on master after all, whatever. So master, they've now had their pull request merged. There is now a new file in here, but I don't have that. So now what I need to do, git status, my branch is up to date, but it's not. So my computer is not constantly pinging a server saying, hey, 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 do I have the most up-to-date changes? No, you need to actually go and say, hey, go and look at the server. Am I up to date? And you do that with, either git fetch. I usually just run git pull because I want the most up-to-date changes. But for the sake of this, I can run git fetch, and it's going to fetch all those changes for me. Okay. Do I have any of those changes now? Nope, I don't have the file. It fetched them, but I don't have anything. So that's the difference between git fetch and pull. Pull will just say, hey, go grab the changes and merge them in. So I'm just going to run that now, git pull. Pull those changes from the server, the remote, pull them down, and merge them into my local copy. So now I have, oh, here's the new file. Fast forward, remote changes md +1. That's 1 line of content. 1 file changed, blah, blah, blah. We now have an up-to-date copy. ls, there it is, remote changes. So now I'm up to date with master. I could actually make a change here, push that up, and now merge it because there's no conflicts. As long as I didn't make a file called remote changes with differing content, it wouldn't even matter if I had gotten the most up-to-date code. But it's usually good to just grab everything up to date, be up to date, and then merge it in. So that is all there is to merging branches on the command line or on GitHub. You just merge using the PR process or the pull request process. So all this is detailed here, git pull. And once we are actually done with that branch, it has served its purpose. I made the document, I pushed it up to the remote, I satisfied the pull request process. Somebody said, yep, that code looks good. Merge it in, we're good to go. Well, then that branch is done. It has served its purpose. I now have my document into production, the master branch. I don't need it anymore. So this is where you run git branch -d, or on GitHub and other front ends for Git, like Azure DevOps, you can just say, hey, merge, and then delete this branch. So we're just going to run git branch -d, which is delete new branch. And it deletes it. Git branch to list them. Only master exists. We now have no more branches. And that's it. Now, I'm going to get into this extension later, but if we can actually look at the Git graph of this repo and say, whoa, what is going on here? This actually might not be the right repo. No, this actually isn't the right repo. Okay, ignore that. So what I might be able to do here is run something. Okay, so in short, you can ignore what I did just here, but this is basically showing you the history of our repo. I created the README, I created the file called new file, and this is where we left off with new branch. Notice it says origin. Here we also have some other stuff in blue, head and master. Head is pointing at master. Head, which is I always wondered, what is that? I don't know what that means. This is where you currently are in your Git repository. I am currently at what? I'm currently at the master branch, the head of the master branch. You can take that and point that at a different commit, but that's like more advanced and outside of the scope of this talk, but you can do some really crazy stuff with this. But really all you need to know is that basically we are pointing at the tip of the master branch. which is also even, which is why it's on the same line, with the origin master, i.e. whatever's on the server, I am currently exactly even with that. They are identical. So if they're on the same line like this in the git log, then they are exactly the same. But we left origin new branch behind. Okay, but that says origin new, so I know that that means origin, that's on the server, not on my computer. So where's new branch on my computer? We deleted it, right? So how do we get rid of this? Because we want that thing gone. On GitHub or Azure DevOps, you can just delete it that way, but let's just say we didn't. I want to make sure that that's gone. What can I run? I can run git fetch, which doesn't just merge anything. It just says, hey, go get those changes. And I can run -- prune. Now, I'm not sure if this will work in this example. I'm used to doing this in a different environment, but if I run that, it's not going to change this. So what I could do, and this is actually not something I was going to include in the talk, but let's just cover it anyways. Git branch -d f, which is force. So when you really want to make sure that something happens, you can force it. Use sparingly. So I can say origin -new branch, because Git knows that the server has a branch called origin new branch. So as far as it knows, I'm just going to say, yep, I know it exists. Go delete that. And force, I mean, go delete that. Enter. And not found. Okay, weird. No. Log. Yeah, so this is actually a bit of the workflow that I'm not familiar with, because git branch, it might not let me do this. Normally when you merge a branch, I just delete it, but it's not playing nice right now, so I'm going to move on. So we've deleted the branch, we've fetched and pruned. What does prune mean? Well, that would mean that if I actually deleted the branch on my remote, I said, we don't need it anymore, I merged it, but now I want to delete it. We can actually delete this branch. Pull requests. Actually, I'm not sure how to just delete the branch right off the bat here. So, let's actually go through a little bit more of the process. Git switch branch, not switch. Origin new branch. Okay, this is not playing nice. I'm just gonna move on. Normally, when you delete a branch on the remote, your local computer doesn't know it's been deleted. So that's why I would still see, this here saying, hey, you know that thing still exists, right? It's on origin, it's on the remote, it still exists. You deleted your local copy, but it's still there. If we deleted that on GitHub or the Git server and ran git fetch -prune, that just says, hey, go give me all the most recent changes. i.e., now I fetch the changes, I know that that branch on the remote repo doesn't exist anymore. So it just says, oh, it doesn't exist anymore, so get it out of here. And then this right here would disappear. So it's pruning. You're pruning a tree. You're getting rid of all these excess branches. You're done with them. Delete them and prune them. Get them off of here. Have a clean working tree. And that's basically the branching workflow in its entirety. Make a branch, push it up, merge it, delete them. They're done. Branches are cheap. You can make as many branches as you want, pointing wherever you want, merge them in, and you're done. Now, there's a little bit of nuances there. You'll make a branch, you'll make your changes. Before you want to merge, you want to make sure you are in line with production. I won't want to have any conflicts or weirdness because master has changed. So if I merge my stuff in where master changed but I didn't, I'm in the past, even though I have a new change, I'm basically going to revert master. I'm going to say, hey, my stuff differs. Merge all of my differences, and that's going to be the new production. But what if I actually needed to have some stuff you had on production brought over, and then I'm up to date with you, except I have a new file. Merge me in. Now the only change that is being done is add a new file. So that's where things can get a little messy, which is why I usually advise, at least in our workflow at my workplace, before we do a pull request or merge anything in, we merge master production into our feature branch. because we're only using a one branch workflow right now, which I will detail a little bit more as we go on. So basically, give me all the most recent production changes. Now I want to merge in, because the only thing different between us, production and my feature branch, is the actual changes that I made. And that's what we care about. Only add the new stuff. Don't revert anything or do anything weird. And before we get into a little bit sped up version of a multi-branch workflow, which is just a little bit of extra work, I'm going to pause and ask if there's any questions so far, because that was a lot. So do we have any questions? Go ahead. I honestly don't know. I was used to using checkout, but I forget when it came out or what version. It might be, I'm not even sure if this is Git 3.9 or whatever, but it's the new version, and they said it's because Git checkout is massively overloaded. So it's literally just git switch, and then you switch to your branch, but you can still do things like checkout-b to create it and hop over to the new one. Yeah, there's it does a lot of things that it's not necessarily, supposed to do. Like, the Unix philosophy, very simple, it has one purpose, it does one thing very, very well. They've added too much functionality to a single command, so now it's doing too much. So that's what they usually mean by overloaded. Yep, I gotta work on this thing. Sure. Mhm. What happens if you have two branches that are trying to merge in at the same time? Mm-hmm. No, I think you're kind of cutting out, Sean. Yeah. Yes. So let's say that you and somebody else both made a copy of master and you are both working on features at the same time. Whoever gets merged first, right now you're both the same. Like, you both have a branch that differs from master, so nothing is the wrong is there is no problem until one of you gets merged in. So now, when one of you gets merged in, the other one is like, oh, but my changes haven't been merged yet. So if I try to merge in right now, some of my stuff might conflict with what you have, which is usually what results, and it's a merge conflict. And so how you resolve those is first, and like I say for my workplace, our workflow is, before I'm merging into master, always pull those changes down and merge them into your feature. So that way you're saying, hey, whatever the current state of production is, wherever I'm trying to go to, give me all the most recent changes from there and merge them into my stuff. Now, if there was a merge conflict, you don't need to get it onto GitHub and handle it up there. You can handle this before you even get it onto GitHub, before you even bother a maintainer with having to deal with your pull request. You can say, okay, before I even open a pull request, get me the most recent stuff, merge it in. Red flag, there's Git, there's a Git conflict, there's a merge conflict. You really just then say, oh, I need to open up that file, and then there will actually be a visual indicator. It'll say, like, incoming change or head, and it'll tell you what's actually trying to come down, what are you merging into you, versus where were you that had the conflict. So it'll basically highlight for you, and then you can choose which copy to keep. So once you do that and you resolve the merge conflict, you chose which of the two pieces of content you want to keep. Then when you request to have a pull request, and say, hey, I'm ready to be merged in, it's going to say whatever the current state of your stuff, that's going to be the new stage of production. So let's just say you didn't like the merge conflict and you're going to keep what you had. Well, the merge conflict's been resolved. You've acknowledged that, yes, I know this was a conflict, but I chose to go with this. That's basically the same as just having a new copy of master and then making that change. So once you merge that in, that all those changes are merged. Everything that you have is merged in. And because of that, if you have a very stale old branch and you merge that in, it's basically like trying to revert and going back in time with your repo when it will try to overwrite the current state of production. So that's why it's always important to try and get your branch merged in with the most up-to-date, copies. And that's usually because different things that you touch change over time. So you do have to git pull to get the changes to what you're working on. If you are, and this is like a very niche use case, if the only thing you're doing is adding something new that doesn't really change or rely on anything else, it's basically its own little vacuum, its own thing, and you're only adding a new file, that doesn't affect anything else. So you technically could have a massively stale branch with old changes and just to have a new file, and you could probably still merge that in without doing a git pull. Maybe, I actually, now I say it, I don't think so. Yeah, it's best to just always git pull and have a up-to-date copy when you're trying to merge in. Any more questions? Okay, the next portion is going to be a lot faster and a lot easier to follow because we've gone through all the hard stuff. Now, what I finished covering with that single branch workflow, production, master, and our feature branch, the one branch that we made. The only difference between that and what you could be doing in an actual work environment, a production environment, is that instead of just having production and master and then saying, yep, I'm ready, go straight to production, is that you might have some intermediary branches. Now this one says release, but I'm basically calling it test. What you might do is you say, I'm going to make a feature. Okay, I'm going to work on it and I'm done, ready to merge in. Well, now you need to send it to first this staging area. Nobody sees this. No end users see this. No, it doesn't affect anybody. But here you're going to do something like, I don't know, develop unit tests, make sure it works with everything else, run some more testing, put it over here, or basically you're staggering your changes until you hit a formal release point. So you could say, this is where we do all of our testing. We make sure it is bulletproof. It works. It's not going to break anything. Then we're saying, yep, okay, this is good to go. We're going to put that here and we're going to park it. We're just going to park that right here until we're ready to actually get, bundle together a bunch of these new changes and features and formally merge that into master as a release. And this is a very, very common workflow. And now at my workplace, we're not doing this quite yet because right now we're only doing documentation and not any sort of serious development. So right now we still do the single one branch features off of the master branch and then merge it into production after it passes peer review because it's just documentation. It's not literal code. So this is actually something you might see on GitHub a lot, especially if it's a very popular and active repository. But you also might see this in a workplace. So we have our basic repository here, git branch, and it's going to say, yep, you only have one. It's master and you're on it. So now what we can do is we can actually make those other branches here. Our release, I'm going to call it test or develop. It doesn't matter. So we're going to actually make new branches and work through a little bit of this workflow really quick. And I'll just go a little bit faster because I think I've harped on some of these commands enough. So git branch, dev, test. All right. So I've made dev and test, and now I want to push -u. Oops, I actually just push origin dev. There's no changes, but now we have a new branch on the remote. It's called dev. Test, same thing. Now if we look at that, refresh. Okay, no changes to this, but now we have dev and test. Ignore new branch, that should die, but I'm not going to get rid of it right now. We have master, dev, and test. Cool. So We've made the branches, we've pushed them, so now the server knows they exist and they are on the server. They're exactly identical to master, so there's nothing to do. But now we actually want to make a feature branch. Now, if we're working off of this workflow, normally if I just say, hey, get branch, new branch, and I make something, that's not pulling off of anything here. And this is actually important. Master is the default of where I'm branching from. But if this is your release and you're working on stuff, and this is your actual workplace, this is where all the actual work is happening on develop, you don't want to pull from master. This is stale now because you can see this is a head. We actually want to pull from develop because this is where everything is, all the new stuff. And when we're going to, eventually merge everything in for staging and then a formal release and fast forward master to a new point, we don't want to pull stale stuff. We want the actual working place. So this is where you might actually see like, hey, there's a release, but it's been like 3 years, but there's been active development on other branches. What's up with that? That's because people are actually working on these and not off of production. So what do we have to do to get a branch off of develop? And it's right here. I'm going to say get branch. I'm going to make a feature. But here's where you actually have an optional argument. Instead of just saying this, get branch feature, which says, all right, make a copy of master, and it's now called feature. That's a branch. There you go. We're going to say get branch feature. We're going to make a branch called feature. But where is it coming from? It's coming from dev. We're going to make a branch off of the development branch, not master. And so now we have that. Get branch. We have feature. That's all you really need to know. So now I could say, look at all these branches now. So now we have test, origin master, origin dev. We also have the local copies, test, feature, dev. There's no origin feature because we haven't pushed it yet, but everything looks good. So now what I can do is I'm going to make a new document, add it, stage it, and commit it. So we don't need this README here, but I'm going to say new file on, actually, I'm still on master. This is where I always mess up. Is if you're on the wrong branch, we actually need to move those changes over. So actually, I was going to show this later, but I'll just show this now. Let's just say I make a new file. I forgot to switch to my feature branch. I'm still on production. That's not where I want changes going, but let's work through this. So feature .md. Okay. This was made on the wrong branch. Okay, save that. Oops, save it. It now exists. So now if I ran git status, it's going to say feature doesn't exist, add it to version control, it's untracked, but we're on, oops, I made a mistake. We're on master. This is where something cool can come in called git stash. I actually discovered this fairly recently, in the last like 2 months. Really, really useful. Let's just say I put changes on the wrong branch. I need to put them in a box, hop over to my new branch, and then open up the box and pull out all those changes. That's what git stash is for, basically, to keep it simple. If I could say git stash, and then just like any sort of array methods, any language you might work with, you might see a methods called push or pop when it comes to arrays. It's basically the same thing. I'm going to push a new stash onto the pile. Okay, I'm just going to say git stash push. It actually might not give me anything because I haven't added anything to version control. Yep, no local changes. That's where you might say git add and feature. Okay, so now it's different. Okay, so now can we git stash? Yes, we can. Git stash, saved working directory and index, blah, 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 blah. All that really means is now I can run git status. Nothing happened on production. It's almost like nothing happened. I can say ls, and there's no feature.md. Where did it go? It's inside of a little box away, not on this branch. It's just floating out there. So now we can do the important thing, which is git switch to our feature branch. Oops, I spelled wrong, that's why. Now I am on the feature branch. I can say git stash. We could also list out all of the current stashes we have open, and then they are denoted with numbers. Like this one is 0 because it's the first thing. This is where, yeah, okay, work in progress on master, blah, blah, blah. Here's the hash. That's interesting. But now we can say git pop or git stash pop, which is, pop the next thing off of the stash. Or if you want to pop off a particular item, you can say the number, which is that index. So I can say git stash pop 0, and now here we go. We're on branch feature. We have a new file called feature.md, and this is exactly where we were on the production branch, but now we've moved it to the right place. Basically, stash will let you pick up and move something to a new branch, which is very useful because I frequently forget to switch branches. So now we have this new file. We are ready to do the whole workflow. We added it. Now we're ready to stage it, which we did. And now we're ready to commit. So git commit -m init feature.md. Okay, we have now committed on the feature branch. There still is no remote copy of feature because feature now here, head points to feature. There's no origin feature. So we're going to have to do it. You guessed it. We're going to do git push origin feature. We're going to push our feature branch up to the remote branch as a copy of itself. Basically make a remote version of feature branch and put it on the remote. And that's done. And now I can run the same thing and we'll see, yep, head feature, origin feature. We now have it on the server. All right. So now we have made a branch off of dev. That branch is called feature because we were working out of a development environment. We have made a new feature and we are now ready to merge that feature into development and then follow the rest of this workflow. You know, develop here, push it over to a staging area. Then when we're ready, take all the new features and make a release. So how we do that is we'll do it on GitHub this time. So now I'm going to say, let's go to, oh, we need to refresh first. Okay. Go to the feature branch. And now this is where the reason why we branched off of dev becomes important. So now this branch is one commit ahead of master. Okay. I don't care about master because we're merging into dev, right? Compare and pull request. So I'm saying, hey, the base is master and I'm comparing feature to master. I could merge this, but that's not where I'm merging this branch to. I am merging this into dev, not master. So now, yep, I am able to merge. So this is the only change. We are going to merge feature into dev. And it's going to do its thing and be slow. Okay, we are ready to merge. I'm going to say, yep, merge it. We're merging feature into dev. The pull request is successful, and this automatically deletes the feature branch. I could restore it, but it served its purpose, so I'm going to delete it. So now if I actually go back to the main repo, and I look at my branches, dev had recent pushes less than a minute ago. That's because I just merged something into it. Feature is gone. There is no more origin/feature. I still have a copy on my computer, but not on here because I merged it in and it deleted. So now dev is updated. So this is usually the way that I do things. And now I could actually run git fetch -- prune if I was not on, the feature branch. First of all, I need to get off of this thing because if it's deleted, I can't be sitting on it. It's like sawing off the branch that you're sitting on in a tree, a literal tree. You can't saw off that branch, otherwise you fall down like a cartoon character. Git switch master. Okay, I'm going back to the master branch. And I'm saying git fetch -- prune. I want to prune my tree, remove anything that is just floating around there. And now this is where I might show this extension, which is called git graph, but this one might not be showing the right repo. One second. Oh, well, it's not going to let me do that, so that's going to be a little bit difficult. One second, I'm going to see if I can show you guys here. Okay, never mind. So we have master and we have feature still, but now we want to actually get rid of that one. So before I do that, git branch, there's feature, git fetch, -- prune. Okay, from GitHub, deleted this branch. So now the branch is gone. It was origin feature, but now it's gone. And some other stuff, blah, blah, blah. And dev was actually updated. So this is just some information, like feature's gone, dev has been updated, I have fetched all of these changes. Cool. If I ran git pull here, it's not going to do anything. There's nothing to pull down from master. I can only pull from, dev now, because dev has some updates. So git switch dev, git pull, and now it's going to say, interesting. So we actually need to say git pull remote branch. So git pull origin dev. Actually, I'm not sure why it's doing that, but okay, moving on. So in any case, now we have dev now has all the most recent changes that featured put into it. So now this is where you might actually cascade your merges. So now I can merge features into dev, but now dev is ready to merge into release, or in this case, test. And then from there, we can actually cascade that merge into master. So I'm going to actually switch to test and say git merge dev. It is already up to date because I couldn't pull those changes for whatever reason. Actually, I might be set upstream. Okay. There we go. Git pull origin dev. It was being a little finicky. So now I have the feature file. This is when dev had feature merged into it. So now I can switch to test, and this is when we are here and we're trying to merge into this next branch. We're cascading down towards a production release. So I'm on test, git merge dev. Now I am right here. I have merged dev into test. Now we could actually make some further changes. We could make some updates, fix any additional errors, package this up for release. And then once we're done and ready, switch to master, git merge test. And now we would have a release, and we could actually, add a tag, which is this v1.0. We could do all of that. And that is basically the cascading release workflow that's used by very, very large projects that need to actually stagger and prepare branches for release. So in essence, the branching workflow is the same. It's just, instead of just only merging your branch into master, you just merged into one branch, which only ever merges into one other, and it just cascades. So you can have as many of those as you want. You could have dev, stage, test, package, release, master. It doesn't matter. It's up to you, whatever you want to do. But there's usually some level of convention where people might say, I only want to have a couple of these where I, package it up, add some tests, do some development, and we're done. And then it keeps everything tucked away into nice, neat little areas and keeps it clean. Now, before I go into how to avoid doing command line shenanigans, because that might actually look complex to people who have never used Git before. I remember when I first learned Git at a free CodeCamp meetup, and I'm like, whoa, that's a lot of stuff there in that command line. There's actually a lot of ways to make it easier. And before I get to that point, which is probably the last thing we're really going to do any sort of talking about, I will stop one more time for questions, because that was probably a lot. Any questions before the last bit? Okay. How to make Git easy. There are different programs like Git Desktop or any other sort of GUI editor for using Git. Git Kraken, Git Desktop, whatever. I don't even use any of those, but there are some extensions for VS Code that make using Git a lot easier. You saw me use GitGraph. GitGraph is, and these will all be here, these are actually extensions for VS Code. GitGraph will show you a visual representation of your graph where everything is. You can open these up, you can actually look at the different changes and see all that different stuff. Who made the change, and then what branches, is it an origin, is it even with origin, all this stuff. We make prolific use of this extension in my workplace to see what's going on and where things are. This is very, very, very helpful. And this is all we really use it for, is just to look. Now, what you can also do is if I open up a file like this one, I also have the Git history extension. This, on these files that are under version control, file annotations, where is it? Git history, there it is, file history. So this will actually that won't show me a lot at all. I actually want to go to there we go. I'm gonna run Git history on my file that I made for this talk. And here we actually have history, each commit, each of its hashes, and this is a little bit more of an easier interface to walk through. So this is the current file is even with the remote head, the remote main. This is basically like everything on production, the server is equal with where I'm at currently. But Git history, very, very useful when you're trying to actually look through the history of a file. You also have Git lens, which is probably the most useful VS Code extension that I have. Git lens, if you use the command palette, right here, Git lens command palette. This basically gives you every command in a selectable menu. You can use your keys. I could say branch, create. What do I want to make this branch from? I could choose, oh, that's because I have multiple repos open, but if I'm on my test one, I can make a branch off of dev and call it feature 2. And now I have a new feature branch. I didn't have to do any command line at all. That is where Git lens is incredibly useful. And also we have the Git menu over here where you can see different things like the branches that you have, and you can make new branches from here. You could work with your stashes here. What are the changes, commits, repos, all this stuff. This is all from Git lens, and it is probably the most useful VS Code extension that I've ever used. So there's a lot to unpack there, but honestly, everything you saw me do today can be done with Git lens for the most part. So have fun with that one, because that is probably the most useful thing ever. And then Git tags, this is really just when you're adding a tag to, like a release. Like I could run Git tag and create a tag and say v1.0, and there we go. And then what's the message? First release. And now if I'm on Git graph, it'll say, oh, there's a tag now, forevermore, there is a tag. But if I don't like that tag, I can always Git tag, and it'll actually show tags if I wanted to. It'll show me here, or there actually is a menu, Git tag, and it'll actually let you push them, and yeah, Git tag. So that's really only useful. You could do that elsewhere on GitHub too, so that's it. We already covered stash. And there are some more advanced topics with Git, like hooks, aliases, bare repos, and this is like, instead of fast forward, you could do cherry picking or interactive rebasing. Kind of advanced. I don't really use too much of that. Aliases I use prolifically, like GS instead of status, GC, or I could do git add, and then GC GP, which is git add, commit, and push, and it's just like 7-8 characters, and that runs through the entire Git operation. Lots of stuff like that. Really useful aliases, and then a litany of helpful resources. The actual Git documentation, the Git book, which is, this book, Pro Git. This is actually on Git's website. You can grab that too. And there's also this really great resource that I found on another free CodeCamp repo called learngitbranching.js. The first 3 or so lessons are probably the ones that have 80% of what you're going to use. This is incredibly helpful for learning interactively Git and branching and commits visually. So highly recommend this resource to solidify a little bit of what I talked about today, because that was a lot, big info dump. But this is an incredibly useful resource you might enjoy taking advantage of. And that is actually all I had to say. Hour and a half-ish talk. Does anybody have any questions before I conclude? All right, I will end the recording now, and thanks for listening.